Welcome, I'm glad you made it. We believe that SerialDB is the ultimate multi-model database for tomorrow's applications. In order to understand what we mean by multi-model and tomorrow's applications, we have to look at the past. Because as a great inventor Isaac Newton said, "If I've been able to see further, it is through standing on the shoulders of giants." Let's therefore go back in time. Ready? Let's go. The world is complicated. How do we make sense of it? Think about it. You thinking about it? Good. I believe your answer fits into one of those two categories, data or stories. Why? Because as long as humans have existed on this planet, we have tried to make sense of it. Just as cavemen drew symbols on walls, we draw symbols on paper, or perhaps more accurately, we type emojis into our smartphones. Well, there's a lot of technology that has enabled us to be this kind of digital caveman. And this technology is kind of often very hidden because you don't interact with it. As we went from physical paper to digital paper, with physical paper, whether it be a spreadsheet or a book or a map, you could actually touch it and feel it and draw on it and whatnot. But with this digital paper, it's all abstracted from you. You don't necessarily see a relational database, a document database, a graph database. You just interact with application. But there has been a lot of innovation in the database space. And we'll focus on database models here. We'll focus on the relational, document, and graph model. And then we'll talk about the multi-model and why that is so important for tomorrow's and today's applications. Starting with the relational model. Now, the relational model is like a puzzle where you have these puzzle pieces, if you look at the picture, and you have three puzzle pieces that fit together and one that's kind of not really fitting together. You could say that it doesn't join together with the others, that there is a join problem, where relational databases are all about joins. So what you need to do to avoid this kind of problem? Well, first, you need to make a plan for which puzzle pieces are acceptable. You're essentially defining a schema. Then you're creating the puzzle pieces. You're inserting data into that schema. And then you're assembling the puzzle pieces. You're selecting which pieces you want. And then you kind of get your answer. You see the big picture. But the trick is, for each answer or for each big picture you want to see, you might have to assemble a lot of puzzle pieces, be that 4 over there or 1,000 or 1,000,000. And this can get complicated quite quickly because you need to know all of these relationships. Specifically, if we look at a practical example here with a fruit box, we have a fruit box and a price list. And we have these two tables. And with a relational model, we have them both here in columns and in rows. And the way you would query the relational database is through language called SQL, which stands for Structured Query Language. And you're essentially selecting everything from the fruit box. You're selecting just the fruit, as in the fruit column from the fruit box. And you're selecting the fruit column and the price column from the fruit box, and you're joining it to the price list so you can get both of them. And that's kind of what relational databases are about. They're about joining things together in this kind of tabular format. And that kind of goes back to set theory, because relational databases are essentially an abstraction over set theory, which I'm not a set theory genius, and I'm guessing you're not. So it is a really good abstraction, and it is an abstraction that is stood the test of time. It was invented in the 60s and 70s, and it's still going strong right now. But it is not the only model that is important, because we don't really think about the world in tables. We kind of think about the world in different ways. And oftentimes we don't actually want to make a puzzle for everything we want. But before we get into that, fun fact about durians, they are the smelliest fruit in the world. And some people love them, some people hate them. But apparently this woman right here wasn't really that happy sitting next to durians all day. Maybe you love them, we'll see. Anyway, back to the document model. The document model came about after the relational model, and oftentimes the document model and subsequent models are associated with something called NoSQL, which originally meant NoSQL, as in this database doesn't use SQL. But a fun fact is that NoSQL was first used for a relational database. But it's besides the point at the moment. What we want to focus on here is that why the document model exists. Well, it exists primarily because relational databases came about before the advent of the internet, and therefore there was a lot of innovation that needed to happen, but also because you don't necessarily want to define a puzzle every time you want an answer. You just want to kind of create a document, and you want to write in it, and then you want to read from it, just a very simple thing. And how does that actually work in practice? So we have the document database here, and we're taking the example of MongoDB and the Mongo query language, where we have a JSON here, and you just put it in this database. So it's not a table. It's actually called a collection, or it's called a document, and then inside the document you have a collection. So we have the Fruitbox collection, and then we have the price list collection, but the data remains the same. Now, the way you query it is very different, where you're essentially not selecting things, you're finding things. So here we're finding everything, so finding everything from the fruit box, and then we're just finding the fruit from the fruit box. Now, I'll leave you to decide whether it is more complicated or simple than SQL, but there are, of course, pros and cons to everything. But the queries are exactly the same in terms of what they're getting. And here we also have a query that's kind of aggregating both from the fruit box and the price list. So we're just getting everything from the fruit box and the price list and showing that as a result. Now, this document model has a lot of pros and cons to it, just like the relational model. And people kind of thought that like, oh, document models are great, let's move everything to that. And then people moved back to SQL. And then some other people were like, hey, we don't really think in tables or documents. We actually think in relationships, in graphs. And so there was another innovation about the graph data model, which is kind of like your social network. You make a map of who knows what and how they're connected. Then you essentially ask around the network for what you want until you find it. A practical example of that is Neo4j with a Cypher query language. Here we have the same fruit box and the same price list, but it's not a table, it's not a document. Now we're talking about nodes and edges. So here we have the fruit box node, which contains an apple. We have like orange and a durian. And then we have another kind of price list node with the prices here. And now we're not selecting stuff or finding stuff, we're matching stuff. So like pattern matching. And so we're matching whatever fits the fruit box, and we're returning from a fruit box. So that's the equivalent of finding everything from a fruit box or selecting everything from a fruit box. And here we're matching the fruit box again, but we're only selecting the fruit from a fruit box. So we're getting the apple, orange, and durian. And the way graph databases join things together is effectively by doing this relational graph things, where you have this edge here called lookup. And so you're going from the fruit box, you're through the edge. So effectively imagine the first dot there is fruit box, then you have lookup, then you have price list. And that's a more natural way of understanding the world, even though the syntax might be a little bit weird. And again, we're returning the fruit and the price. So all of these from the relational model, from the document model, and from the graph model display the same thing. So we're selecting everything from a fruit box, we're finding everything from a fruit box, and we're matching everything from a fruit box. And the data is different. It's rows and columns, it's JSON, and it's kind of like this node syntax. Now, we have all these models of understanding the world, and they're kind of necessary because they all have pros and cons, and they help us to have a more greater, fuller perspective of the world. That's why oftentimes when you have a complex application, the application would use all of the models. So you have a relational model, you have a document model, and you have a graph model. And you probably have a dedicated database for each. And this can be very complicated because you're having to learn multiple query languages and you're having to deal with multiple ways of the data being structured. And if you just want to focus on your application, you don't want to learn all these different languages, you don't want to learn all these different data modeling techniques and all these kinds of stuff, what do you do then? What are your options? And that's kind of where SurrealDB comes in. SurrealDB takes all of these models and takes all of these ways of understanding the world and querying the world and kind of puts it into one coherent way of doing. SurrealDB has a SQL-like syntax, but a document-like data structure. Now, this has several advantages where it allows you to have both the flexibility of starting with a schemaless approach, like in MongoDB, where you're just rapidly prototyping and starting things and going. But we also have the concept of tables, which allow you to have schema full and allow you to make things very defined in terms of types and all the guarantees that comes with the SQL relational approach. So select star from Fruitbox, select fruit from Fruitbox. But now we have a different way of joining the data together. Here we have select fruit and then price list.price from Fruitbox. Now this price list.price is effectively a join. And if you look at the kind of way it's stored in a document style structure where we have the Fruitbox table or node, if you will, and then we have the other price list one. And in this example, we're essentially embedding the price list information in there. But there's a different way of doing it. Here we have a more graph style where, again, we have the Fruitbox, we have the price list, and then we have this lookup table. And now we can select the fruit, and then we can go from the lookup table, go to the price list, find the price from the Fruitbox. Because if we see here in the bottom, you have the ID of the lookup, you have what it's looking up from, and what it's looking up to. And there we can see how you can join things together. Now, SurrealDB also has a lot of other cool stuff in it. It's serverless, embedded, ACID, full-text search, real-time events, temporal, scalable, many clusters, and so forth and so forth. There is a lot of innovation going on, and SurrealDB is embracing a lot of this innovation and putting it in a package that is very easy to use, but very flexible. And that's all I have for you today. What I would really encourage you is to sign up for our event, surrealdb.world, where you'll join with us, where we will have our latest innovation unveiled. There will be exciting announcements that we believe will shake the future of the database industry. It's on September the 13th. I hope I'll see you there.